Assalamualaikum everyone and very good evening. Today our group will present our project titled Interactive CPU Simulator Visualizing Fetch Decode Execute Cycle. This, this project is about helping students understand how the CPU works inside a computer system. Many students know that the CPU is the brain of the computer, but they may find it difficult to imagine what happened inside the CPU when instructions are processed. The problem we want to solve is that the fetch decode execute cycle is quite difficult to visualize. Students may memorize the step, but they may not fully understand how the CPU components works together. Our project is an interactive CPU simulator that show the movement of instruction and the data step by step. It helps users see how memory register, the control unit, and the ALU works together. The objective of this project are first, to demonstrate the structure of the CPU including the ALU, control unit, register and memory. Second, to simulate the fetch decode execute cycle in a clear and visual way. Third, to help user understand how idea.
Thank you. Now I will explain the main components used in our CPU simulator. The first component is the control unit. The control unit controls the operation of the CPU. It reads the instruction and decides what the CPU should do next. The second component is the ALU, which stands for Arithmetic Logic Unit. The ALU performs calculations and logical operations such as addition. The third component is the registers. Registers are small storage areas inside the CPU. They temporarily store data and instructions while the CPU is processing. In our simulator, we use several important registers. The PC or program counter stores the address of the next instruction. The IR or instruction register stores the current instruction. The MAR or memory address register stores the address of the memory location that needs to be accessed. The MDR or memory data register stores data and instruction taken from memory. The ACC or accumulator stores the result of a calculation. We also use memory. Memory stores both instructions and data. For this simulator, we use a simple program. The first instruction is load 10, which means load the value from memory address 10 into the accumulator. The second instruction is add 11, which means add the value from memory address 11. The third instruction is store 12, which means store the result into memory address 12. The last instruction is alt, which means the program stops. The values used are 5 and 3, so the final result will be 8. Next, the third presenter will explain the fetch and decode process.
Thank you. Now I will explain the fetch and decode process in our CPU simulator. The first stage is the fetch stage. In this stage, the CPU gets the next instruction from memory. At the beginning, the program counter or PC contains the value 0. This means the CPU will fetch the instruction from memory address 0. The value from the PC is copied from into the MAR, which is the memory address register. The MAR tells the memory which address should be accessed. Then the memory address 0 is selected. The instruction stored at this address is load 10. This instruction is sent from memory to the MDR, which is the memory data register. After that, the instruction moves from the MDR into the IR, which is the instruction register. Now the IR contains the instruction load 10. After the instruction is fetched, the program counter increases from 0 to 1. This means the CPU is ready to fetch the next instruction. The next stage is the decode stage. During decode, the control unit reads the instruction inside the IR. The instruction is load 10. The control unit identifies that the operation is load and the address is 10. This means the CPU understands that it needs to get the value from memory address 10 and place it into accumulator. In simple words, fetch means getting the instruction while decode means understanding the instruction. Now the fourth presenter will explain the execute process and final result.
Thank you. Now I will explain the execute process and the final result of our simulator. After the instruction load 10 is decoded, the CPU executed it. Memory address 10 contains the value 5. This value is moved into the accumulator or ACC. So now the ACC contains 5. Next, the CPU continues to the next instruction, which is ADD 11. Memory address 11 contains the value 3. This value is sent to the ALU. The ALU adds the value 3 with the current value in accumulator, which is 5. So the calculation is 5 plus 3 and the result is 8. The result is then stored back into the accumulator. Now the SEC contains 8. After that, the CPU executes the instruction store 12. This means the value in the accumulator will be stored into memory address 12. So memory address 12 now contain the final result, which is 8. Lastly, the CPU reaches halt instruction. This means the program has finished running. In conclusion, our interactive CPU simulator helps user understand the fetch, decode, execute cycle. More, more clearly, it shows how instruction move from memory to CPU and how data is processed step by step. This project make an abstract topic easier to understand because user can see the process visually. This is all from our group. Thank you for listening.